Namaskar, my name is Vinayak Bhatt, a student of Graphic Era Hill University, BTech Mechanical Engineering 6th semester. I am here to deliver a video on the topic of design of helical gear.
First, we have to identify why we use gear. A gear is a simple mechanical device which is used to transmit power from one part of a machine to another part of a machine. The advantage of gear against the other transmitting mechanical components are no slips and equal velocity and power distribution. But also due to this phenomena, the gear imposed to the maximum amount of shear and wear and tear load. So today I am going to describe how we design a helical gear. So why we choose helical gear? A helical gear is similar to the spur gear, but its tooths are cut at an angle to the axis parallel to the shaft. This angle is known as the helix angle. This particular angle allows smooth contact and smooth meshing of teeth and gradual loading and deloading of the tooth during the meshing. So first we will describe the helix angle. A helix angle always varies from 20 degree to 45 degrees. Now another important term here is formative number of teeth. This is defined as the number of teeth required on a simple drum to grave a helical gear. Now another terms are addendum, which is 0.8 times of m. Here m denotes the module. Dedendum is 1 times of module at minimum. Design procedure. We uses a simple formula which is written over here, that is Wt is equal to P by V into Cs. Here Wt is the tangential load acting on the gear or on the tooth. P is the power transmitted by the shaft on which the gear is mounted. V is the velocity of the pitch line velocity of the gear, and Cs is the service factor. Due to certain conditions, we assume that the gear is working on a simple condition with 8 to 10 hours of use. So we take this particular CS as 1. Now this is the Lewis equation for the gear, that said that Wt is equal to sigma O into Cv into B pi m pi y prime. Here sigma O is the permissible load, allowable load for the gear or the pinion. Cv is the velocity factor. B is the thickness of the tooth. M is the module, and y prime is the Lewis form factor corresponding to the number of teeth. Here Cv can be written Cv is equal to 6 by 6 plus V for a velocity of 10 meter to 5 meter per second, and 1.5 to 1.5 plus V for 10 to 20 meter per second. For the velocity greater than the 20 meter per second, V uses this particular formula, that is 0.75 by 0.75 plus under root of V. For the non-metallic gear, this formula is 0.75 by 1 plus V plus 0.25. Now the wear not only faces the tangential load but also the dynamic load. The dynamic load is nothing but a sum of tangential load acting on the gear plus the incremental load that keep on increasing. So the Wt remains the same. The formula of Wv is equal to 21V plus B cos square alpha plus Wt cos alpha by 21V plus under root BC cos square alpha plus Wt. Here The alpha is the helix angle. Also, the gear also get imposed to the shear load, that is WS, which is equal to sigma E B pi my prime. Here sigma E is the flexural endurance limit. Also, the wear load is defined as dpkw bq by cos square alpha. Thank you.